All right, so in part A and B, you're graphing lines. So we usually get them in the form of y equals mx plus b. How come in part A your sign flipped over from less than to greater than? You had to divide by -1, good, to get the y by itself. So your sign flipped. So when you graph this line, we start at a y value of -5. Our slope is up 1 over 1, which means we also cross at 5 on the x-axis. Did you connect this with a solid or dashed line? A dashed line. How do you know that? Good. It's not equal to. This is going to be a dashed line. All right. And with inequalities, we have like a region of solutions, meaning we're going to shade where are all the y's bigger than that line. Greater than means above, right? So my go-to trick is I find the y-intercept and I go above it. So that's going to be this part up here. You can also test a point to see if it works. All right, part B. My sign did not change this time because all you have to do is subtract 2x to the other side. So when we graph this one, we start where y is 10. And we go down 2 and over 1. So that means we're going to cross at 5 again. Did we connect this with a solid or dashed line? This one is solid. All right, and are we shading above or below this time? Below. This one is below. So this was a solid line, bless you, because it's equals to, and we're going to shade below. So again, my trick, I find the y-intercept, and I go underneath, so I know this is all under the line. All right. For lines, I usually find the y-intercept, and I go above or below the y-intercept. You can also test a point if you want to, which we're going to talk about here in a minute. Okay, so that is doing inequalities with lines, which is very Algebra 1. We're not in Algebra 1 anymore. You're in Algebra 2. Okay, so what we're going to do today is we're going to do quadratic inequalities. Okay, so a quadratic inequality in two variables, which means there's an x and a y, can be written in one of the following forms, where a, b, and c are real numbers, and a cannot be 0. Okay, so they are in standard form, and we have y by itself on the other side. Which one of these are going to have a dashed parabola? The first two, yeah, because these are not equal to. So we're going to circle those. Those are dashed. And which ones are going to have a solid parabola? The last two. So that rule is still the same, okay? You knew how to do it in the warm-up. It's the same thing with your parabolas, okay? My trick for y'all with shading with lines is I went above or below the y-intercept. What do you think I'm going to look for on parabolas? The vertex, yeah. So I'm going to find the vertex and go either above or below the vertex, okay? We good? Yes? Okay. So remember that speed graphing I talked about yesterday? That's going to come in handy today. Again, you have your graphing calculators. So if you still want to type it in and get a table of points that you want to plot, that is still a resource that you can use. Okay? So previously we graphed two lines. We can do the same thing. When the test point, so what we're going to do is after we graph, I am going to show you how to test a point, okay? And if that point makes the statement true, then that point needs to be in the shaded region, okay? If the point that we test makes our statement not true, then that's not going to be in the shaded region. I need to shade somewhere else on the other side, okay? So let's do these guys. So I have y is less than or equal, or not less than or equal to. Y is less than negative x squared minus 2x minus 1. Okay. I'm going to do my vertex. So I'm going to do opposite b over 2a. So opposite of negative 2 divided by 2 times negative 1 gives me 2 over negative 2, which is negative 1, right? And then how do I find the other part of my vertex? Plug it in. So y equals negative 1 squared minus 2 times negative 1 minus 1. Come on, pen. There we go. So negative 1 squared is positive 1, but there is a negative out front, so this stays as a negative 1. This becomes positive 2 minus 1. So what is that, 0? Negative 1 plus 2 is 1. 1 minus 1 is 0. So our vertex is going to be at negative 1, 0. Right there. Can I do speed graphing with this? Yes, because my A is a what? Technically, it's a negative 1. So that means I'm going to do my speed graphing. I'm going to do it down. So we're going to go down 1. Then we're going to go down 3. And then down 5. So that's our speed graphing. Before I draw my parabola, is it going to be a dashed parabola or a solid parabola? It's going to be a dashed parabola. All right, and are we going to shade above or below it? It's less than, so we're going to be inside the parabola, right? I find my vertex, and I'm going to go under my vertex, so that means it's going to be inside my parabola. Okay. You can always test a point. Okay, you can always test a point. My favorite point to test is the origin. I feel like it's one of the easiest ones to go with. So if I test the origin in this one, right, 0, 0, I'm going to plug those into my original equation. So 0 less than negative 0 squared minus 2 times 0 minus 1. This gives me 0 is less than negative 1. Is that true? No, that is not true. So you see how the origin is not in the shaded region? Okay, so that verifies that we did shade in the right place. So you can always plug in the origin. 0, 0, I feel like it's the quickest way to do it to make sure that your shade is good. Okay, this was cutting it pretty close on if the origin is actually in there or not. So if you want something more visual, you could have done like 3, 0 if you wanted, or something on the y-axis. 0, 5, something like that, if you want something more obvious. Yes, no, maybe? Yeah? All right, let's do another one. All right. Here, I have y is greater than or equal to x squared plus 2x minus 8. So again, I'm going to do my opposite b over 2a. What point can I go ahead and plot, though? I didn't bring this up last time. What point can I go ahead and plot? Negative 8. Yeah, I know we're going to cross at negative 8 on the y-axis, right? Because this, our c value is our y-intercept. So I know that point's there. All right, let's still find our vertex, though. So opposite b over 2a. So opposite b, which is 2, divided by 2 times a, which is 1. So negative 2 over 2 gives me a negative 1. Let's plug that in to get the matching y. So So we have negative 1 squared plus 2 times negative 1 minus 8. So that's 1 minus 2 minus 8, which gives me negative 9. So our vertex is at the point negative 1, negative 9.
I thought it'd be negative 11. Oh, never mind.
Okay. So there's my vertex. Can we do speed graphing? Yeah, my A value was 1. I already kind of have it going there with that y-intercept. So up 1 over 1 on each side. And we can go up 3. 1, 2, 3. Bump it over. And then up 5. And I think this one you can even go 7. Like that. Are we going to connect these with a solid or dash parabola? Solid this time. All right, if I do my shortcut, am I going to shade above or below the vertex? Above, right? It's greater than this time. So above the vertex would be inside my parabola again. How can I make sure that I shaded in the right spot? We can test something. So I'm going to test 0, 0 again. So if I shaded correctly, then 0, 0 will give me a true statement. Okay, so let's test it and see if that works. Swoop, come back. So is 0 greater than or equal to 0 squared plus 2 times 0 minus 8? So is 0 greater than or equal to negative 8? Is that true? Is 0 greater than negative 8? Yes. So that verified that I did shade in the right spot. My origin should be in my region. How are we feeling? You okay? Right. So now we're going to go backwards. Woo. Now, I'm going to make you write the equation of the parabola. So we're kind of dipping into Unit 2 here a little bit. Both of these have the vertex labeled, so I'm going to write them in vertex form. Okay? If you wanted to do standard form, you can. The first one has intercepts labeled. If you wanted to do intercept form, you can. They would all be correct. Okay? I'm going to be consistent with both of them and just do the vertex both times. Okay? So to remember what vertex form is, bring that back. We have y equals a times x minus h squared plus k. Like that. And we have almost all my pieces. We remember this from before. I need to replace a, h, and k with the value. And what do we never have? We never have a. But I can replace everything else with points that I've been given on my graph. So let's use, so we know this is our vertex. So h is going to be negative 1. Let me zoom in for y'all. H is going to be negative 1, and k is going to be negative 8. What do you want to use for x and y? He's very passionate about this. Are we good about 1, 0 being x and y? Okay. Sounds great. X and y. All right, so we're going to do 0 equals a times 1 minus negative 1. So that becomes plus 1, right? Squared. And then minus 8 on the end. 1 plus 1 is 2. 2 squared is 4. Add that 8 over. Divide both sides by 4. I have 2 is my A value. So this is almost the same as before. Bless you. We have y. My A is now a 2. My vertex is going to be x plus 1 squared minus h. But it's not going to have an equal sign in between. I got to make sure I put the right symbol. Okay? Did it get shaded above or below the vertex? Above. So is that going to be greater than or less than? Greater than. And is this parabola dashed or solid? It's dashed. So do I need to add something to my symbol or am I good? We're good. So this is my inequality. Like that. Think you can try the next one? I bet you can. So you try the next one. All right. So up to this point was from our last chapter. So what was new today is can you pick the right symbol? All right. So review from last chapter, you got an A value of 2. Our vertex is 1, negative 3. So is it greater than or less than this time? It is less than. And how did you know that? Because my shade was under my vertex. Here's my vertex. My shading is underneath it. Okay? Did you put an equals to or not this time? You did? Why? Because it was a solid parabola. Good. All right, good. Are we good with graphs? Feel okay with them? Yeah? So even though we suffered through chapter 2, you see how it's kind of helping us? A little bit? Okay. Someone have a question? I thought I saw a hand. Okay. Here we go. So now we're going to solve an inequality with one variable. Means there's no more y. Okay? My y is now replaced with a 0. Okay? So a quadratic inequality in one variable can be written as one of the following forms, where a, b, and c are real, and a cannot be 0. Okay? So this time, when we graph them, we're going to graph them on number lines. Okay. I think it was this class or next class that gave you like the less than, greater than trick. Do you remember saying? Was that y'all? Somebody else? So like the less than, right? And then there was greater. So on a number line, the less than was when they met in the middle, right? And then the greater is when they bounced away. So like if my example looked like this first one, would they be meeting in the middle or bouncing away? This first example, what symbol is that? It's a less than. So are they going to meet in the middle or bounce away? They're going to meet in the middle, okay? We also need to know if it's closed or open dots. So this one, they're going to meet in the middle, but they're going to have open points on the end. So that's like our dashed line. We represent it with open points. All right, the one right next to it is a greater. So we're going to go opposite directions, but also with open points. And then my last two, less than or equal to. So we meet in the middle, but we have closed points this time. Our last one is greater than or equal to. Wait, what did I do? No, I'm right. Greater. So we have closed points, but going opposite. Like that. And just like the front, you can always test numbers to make sure that you've made them go the right way. Right? So now we're going to solve them algebraically. So looking at our first one, x squared minus 3x minus 4 is less than or equal, or not equal, less than 0. So we have to solve. How do you solve quadratics? We have all the different ways, right? There's basic factoring, there's slip and slide, there's complete the square, there's quadratic formula, right? All the different ways. Which one can we use for this problem? We can always use quadratic formula. Can we use any of the shortcuts? My a is a 1. Can I do basic factoring? Does something multiply to give me -4 but add to give me -3? Yeah, -4 and +1. When we're solving, we make it equal to 0. The less than symbol comes into play when we actually graph them. Okay, so right now we're just finding where my points are. All right, so we have x equals 4 and x equals -1. So when I plot those points, because of the symbol, will they get open or closed points? They will be open. So -1 and 4. It's less than, so should they meet in the middle or bounce away? They should meet in the middle. How can I make sure that I did that right? You want to test something? You want to test 0? Let's test 0. Let's just make sure. So if I test 0, test x equals 0, we're going to have 0 squared minus 3 times 0 minus 4 is less than 0. So this gives me, all right, is the statement -4 is less than 0? Is that true? Yes. So did we shade it in the right spot? Yes, we did. Okay, so we are correct. We shaded where we should have shaded. We're still okay? Okay. All right, next one. We have 3x squared minus x minus 5 is greater than or equal to 0. So before I do anything, we have to solve for x. Can I do basic factoring this time? No, we can't. Can we do slip and slide? Well, if I slip 3 to the end, I get 15. Does anything multiply to give you 15 and add to give you -1? No, so that's not going to work. We're going to have to quadratic formula this one. I know it's your favorite. That's why I did it for you. You're welcome. So, when we set this up, x equals -b plus and minus the square root of b squared minus 4ac all over 2 times a. Bless you. -1 gives you +1. That ends up being what? 1 plus 60, right? Inside the biradical. So that becomes 61. And we are being divided by 6. All right, so am I going to have some real solutions? Yeah, because it's not negative, so we can keep going. Yesterday it was negative and we stopped. Can I plot the 1 plus square root 61 over 6? No, let's make these decimals. Okay, calculators. They're nice. So let's figure out their decimal equivalent. All right, so 1 plus the square root of 61, and then I'm going to divide that by 6. And then 1 minus the square root of 61, and I'm going to divide that by 6. So I have about 1.5, and then about -1.1, 1.14. Yes? You okay with that? All right, so when we're plotting things like this, make them into their actual decimals. Okay, so x is approximately about negative 1.14 and about 1.47 or 1.5. All right, when I plot those, are they going to be open or closed points? They will be closed points this time. So negative 1.14 is like barely underneath it. And 1.47 is almost right in the middle. All right, are they going to meet in the middle or bounce away? They're going to bounce away. How can we check? We could plug in 0, right? So if I plug in 0, those cancel. Is negative 5 greater than 0? No, so I shouldn't have 0 in my shade, so we're good. That being a false statement. All right. Everyone's favorite, the modeling real life example. All right. An archaeologist is roping off a rectangular region of land to dig for artifacts at Lake Jackson Mounds State Park. The region must have a perimeter of 440 feet and an area of at least 8,000 square feet. Describe the possible lengths of the archaeological region. I can't say the word. So we're going back to some geometry, some algebra 1 here. Perimeter and area. How do we find perimeter?
2 times each of the sides added together.
Yeah, so 2 times each of the sides added together, right? 2L plus 2W. And my perimeter has to be what? It has to be 440. My perimeter has to equal that number. So 2 times of each length. 2L plus 2W has to equal 440. And then my area, though, my area was an inequality. My area has to be at least 8,000 square feet, right? So it has to be greater than or equal to 8,000. Our area has to be more than 8,000 or equal to. How do we find area? Length times width. Good. All right. We're going to do a little substitution here. So it's kind of tying in yesterday with what we're doing today. We want to know the possible lengths, right? So I want L to be in my equation. So what I'm going to do is I'm going to substitute the W with L. Does that make sense? So in my perimeter equation, I'm going to solve for W so that I can substitute that into my area equation. You with me? Okay. So over here with my perimeter, I'm going to factor out the 2. I'm going to divide both sides by 2. And then I'm going to subtract the length. Like that. So we're going to use this for our substitution. We're going to plug that in to this W right here. Because you only want L in your answer. It's asking for the length specifically. Words are hard today, man. All right, so instead of length times width, now it's going to be length times 220 minus L. That has to be greater than or equal to 8,000. Are we okay? I'm going to distribute the L. So I'm going to have 220L minus L squared greater than or equal to 8,000. Now I'm going to write it in standard form. So my negative L squared is going to be first. Then my positive 220L. And we're going to subtract 8,000 over. So that way that side is 0. Did I lose anybody with that step? All right. This doesn't seem like fun numbers, does it? Can you think of something that multiplies to give you 8,000 and adds to give you 220? No, because there isn't. So what we're going to do is we're going to use our calculators. Okay? We're going to use our calculators. We're going to graph this and go from there to find our intercepts. Okay? So y equals, what am I doing? I need to do this so you can see it. Here we go. Back to y equals. Clear this out. Alright, so we have negative x squared. Does it matter that I'm using x instead of L? No, it's a variable. Plus 220 x. Oop, I forgot my plus. And then minus 8,000. All right, go to our graph. What's going to be the issue? You already know it. We're not going to be able to see it, right? So we got to zoom out. Zoom out is 3. Push enter. That's not going to help me either. Do it again. Zoom out. Enter. Oh, we're getting somewhere. Zoom out. We're just going to keep doing it until I see it. Okay, there we go. I don't need to see the whole thing, right? I just need to see where it's crossing the x-axis. Make sure you push enter again. So zoom, push the number 3, and then when it gets back to your graph, push enter again. And it'll do it, yeah. So make sure you get to where you can see it all. And then here we're going to find our x-intercepts, which is our zeros. So second trace, find our zeros. We need Blinky. Where you at, Blinky? Oh, there it was. All right, so the left side of Blinky, so down here. This isn't the best problem. You can't really see a lot of it. So my one intercept is about 46, right? And then my other intercept, for time's sake, I'm going to tell you, it's about 174. So are we looking where my parabola is above or below? I heard it. Say it again. Someone said it over here. Above, yes. So we're looking here. So we're in between. So my links, my possible links, are going to be in between 46 and 174 feet. Like that. All right. Good job. Jayla, do you have a question?